All right, guys, so today we are doing 5.4 systems of nonlinear equations. Sub should have for you guys a classwork, and then I printed out the homework in there. You actually have tomorrow's class or next class's classwork as well, but you don't need that today, just the classwork for the two videos, and when you're done, start the homework. All right, so systems of equations. How can we solve a system of equations? If you guys remember, right, you can do it algebraically and graphically. Graphically, you can do it by hand, not the best though, or a graphing calculator. And then there's substitution and elimination when we do these things algebraically, and we'll focus on those today. I'm going to skip the first example. If you're going to do substitution with it, this is actually a line, even though it doesn't look like it. I would simplify this one down. And then if you're using substitution, I would say, all right, well, I'm going to plug in this for that y. That way you only have x's in your equation. Once you get x, then plug it back in to get the y. And that's like your substitution step. Elimination, I wouldn't even worry about doing it that way with substitution. Elimination, I would just, boom, right there. Y minus y is 0. You eliminated the y. Obviously, you have to simplify that one down to do that as well. But that's my go-to typically. And if you want to see this all done out, I have it on the completed notes. You can check those out. And then if you're going to graph it by hand, again, it's get that into y equals mx plus b. Graph it. Graph the other one. Graphing calc would be a lot easier. Notice how, like with these decimals, you graph this by hand and still not get those as your obvious answers because they're decimals. So not preferable for doing it by hand. But we're going to focus on ones like this today. So you can see I do have a line. This bottom one is still a line, but the top one's a quadratic. So if you think about a line with a quadratic, in terms of intersections, you could have two of them, right? It's also possible to have none of them, and it is possible to have one of them if it just touches the quadratic, if the line just touches the quadratic, creates a point of tangency. But we're going to do this with substitution. So if I was going to use substitution, I would say, all right, well, they're both in the y equals form. So I'm going to plug this in for y, and we're going to get 2x minus 2 equals x squared minus x minus 6. And when I do it that way, I can see that I have a quadratic right here. So once I have it as a quadratic, I'm going to set it equal to 0. So I'm going to say 0 equals, and then we're going to have x squared. It's going to end up being minus 3x when you have negative x minus 2 more, and then minus 4, because it's going to be negative 6 plus 2. And then lucky for us, this one's going to actually factor. Otherwise, we'd have to use the quadratic, but we don't have to in this example because when I do it this way, it works. Negative 4 and positive 1 will multiply to negative 4 and add to negative 3. So I'm going to get my two answers, right? I'm going to say x equals 4. Not final answers, though. And x equals, this is really lagging here, negative 1. And so those are my two x values, but if you remember about systems of equations, you got to write your answer as a coordinate point. So I need to take my x's and plug it into either equation. The bottom one looks obviously a lot easier. I'm going to use that one. So when I plug in 4 for x, 2 times 4 is 8. 8 minus 2 is 6. So one answer, you want to write like a coordinate. So 4 is the x, and then 6 is the y. And now if I plug in negative 1 for x, 2 times negative 1 is negative 2, minus 2 more, that would give me negative 4. And so those are my two answers. You want to write them in coordinates, as coordinates. Elimination, I would say, is probably even easier, to be honest with you. If I'm going to do this, I'll just rewrite it. If you have like one of them is x squared like we do, try and keep that one on top. That way when you subtract down, you have a positive leading coefficient. I always think that's easier. So I'm going to write these right on top of itself, and I'm going to line these numbers up vertically. So I'm actually going to write the 2x over here, and then the minus 2 underneath the minus 6. And that way when I subtract these things, oh boy, this is slow. But I'm going to eliminate basically the letter y. Y minus y is 0. That's why I like elimination. It gets it equal to 0 a lot. on its own. I don't have to rearrange like I did with substitution. X squared minus nothing is still going to be x squared. Negative x minus 2x is going to be minus 3x. Remember, we're subtracting. Negative 6 minus negative 2 would be negative 6 plus 2, so it's going to be minus 4. And at this point, I'm not going to redo the math. I already did this. I'm just going to draw an arrow right to there and say, look, I already did this. I already factored it. You don't have to do it again. Just go right to your answers here and just say, all right, well, I already did it. I got 4, 6, and I got negative 1, negative 4. And I'm fine if you guys do that on the homework questions if it says solve both ways. Once you get it to match the other one, just draw your arrow and then write your answers and you're fine. And they should match, right? It's a different way to solve the same question. If you're going to do this graphically, you could graph this parabola, negative b over 2a, all that jazz. But you'll get a parabola in a line, and then look, my 2 points of intersection is negative 1, negative 4, and 4, 6. So it matches my 2 answers, which is great. And my second example is going to be this one. So again, it's another parabola with another line. And so if you guys want to pause the video and try this one on your own, you certainly can. If you don't want to, that's okay. I'm just going to do it up here. I'm actually going to do elimination first, right? I'm going to say y equals, we got our x squared minus 2x plus 1. And then y equals, and then we got x minus 3. And so when I do it this way, just subtracting these down, I get 0 equals, and we have x squared, negative 2x minus another x would be minus 3x. And then 1 minus negative 3 would be 1 plus 3, so we get plus 4. Now this is tricky. Things that multiply to 4 and add to negative 3, that is not factorable. So I would actually have to use the quadratic formula for that one. And then I'm just going to leave it right here. But you would want to use the quadratic formula, actually solve those out. I'm just going to jump to the answer in a second. Substitution, if I did it that way, I would substitute this in for that. And so I would get x minus 3 equals x squared minus 2x plus 1. And again, I would subtract this off, make sure it's equal to 0, and you get x squared, that same thing we just had, minus 3x, and plus 4. And I just draw an arrow to this one and be like, look, I already did this one here, although we haven't finished it, but you could do it that way. I'm just going to jump to my completed notes, which I have already saved, just to kind of save the work here since we're doing the video. This is my one from last year. And so I don't think I've changed these for this lesson here. And we have, just to show you guys, right? So this is the example we just did, right? We did it, and we got something that wasn't factorable. So when we plug it into the quadratic formula, we get these answers. So we get for x 3 plus or minus I root 7 over 2. That's already complicated enough. It's an imaginary number, which we'll talk about in a second. But then, if you want the y coordinates with the x coordinates, you need to plug this in, technically both of these in, these are two different numbers, in for x within this. So you can see, I plugged into this bottom one here. So I did, you can see, I did 3 plus I root 7 over 2, and then minus 3. 6 over 2 is the same thing as 3. That's what this work means. And the only reason I did that is to get a common denominator. And then, basically just 3 minus 6 would be negative 3. The plus and minus I root 7 would stay over 2. So that's the y coordinate. X coordinate, y coordinate. I wrote them separately to show that like the plus goes with the plus, the minus goes with the minus. I would want you to do that. You do need to write these out separately. You can't just say plus and minus, because that could actually mean 4 different answers if each plus went with each plus minus and each minus went with each plus and minus. Does that make sense? So those are your 2 answers. They are imaginary, which tells you on the graph what that means is that you would actually have still a parabola, still a line, and if you have imaginary answers, that means they just don't intersect, right? But the answers that we just got they wrote on the other side. That's the answer to the system, but graphically there is no solution that you would be able to get. So you have to do these with substitution elimination. So a little bit of both. There is some group practice here. You guys can pause the video and do these if you want, but honestly, I'm okay if you just went right to the homework at this point. If you know how to do the homework problems, you would have known how to do these. Quick summarizer as well before you start the homework. Substitution first steps, get either a y or an x by itself and then substitute it in. Elimination, just line up the y equals if you have them or line up the x's. Make sure the coefficients are the same so that you can eliminate. And then graphing calculator, if you're using your actual graphing calculator, if they're not y equals, you have to get them into y equals so that your calculator will be able to punch them in. But that's it. You're good. Good job today, guys. And you can start the homework.